We need another concept called the social cost of carbon. Some people say this is a number that is most important, but you never heard of it. Okay, what is the social cost of carbon? From Carbon Brief here, you can see the social cost of carbon tries to add up all the quantifiable costs and benefits of emitting 1 additional ton of CO2 in monetary terms. So easy to say, but not at all easy to do. This value can then be used to weigh the benefits of reduced warming against the cost of cutting emissions. So economics is always about cost-benefit ratios. So if you have a social cost of carbon, then presumably you can easily use that to say we spend this much to reduce this much carbon dioxide, and these are the benefits. So the point of the chapter is that it's not easy to do, and yet there are many estimates being put out, as I will show a little bit later on. Okay, so these are typically done by using what are called integrated assessment models. These are models, as we'll see a wiring diagram next, are models that take input from climate models as far as change in climate is concerned, temperature, precipitation, and so on. And they produce these movement of materials from socioeconomic activities into emissions, and they can feed back to the climate change models. So climate change models are what are called Earth system models, focused entirely on the physical aspects with some input about human activities on emissions, because that affects climate directly and so on, and deforestation, agriculture, etc. But generally they are about energy balance and how that affects climate as we know it. Winds, rain, temperature, ice, sea ice, glaciers, sea level rise, and so on and so forth. Whereas integrated models simplify the climate as just as an input, and then they move things through these socioeconomic activities, as we will see. So they combine together 4 elements. This is also from Carbon Brief. First, there are socioeconomic projections. How many people will be alive in 2150? How fast will the economy grow next century? How much CO2 will humans emit? And so on. So that's all about socioeconomic aspects of the future. Secondly, there is a climate module, so it simplifies things. How will the climate change in response to CO2 emissions? How quickly will sea level or temperature rise? What about rainfall patterns? So it's not doing the entire climate model, so it's just getting input into that module from hopefully a climate model. There may be some that do it in a very simple way, but not anymore, because we know how complicated climate is. The Earth system is. Thirdly, benefits and damages. How will climate change affect crop yields, for example? What is the cost of living with or adapting to sea level rise? How do increased temperatures affect labor productivity or energy used for heating and cooling? Fourth is the discounting to value future benefits and costs in today's money. In economics, it basically comes down to doing cost benefits, where you are investing today for the future. So you have to take some discount rate, which we will define soon. Basically how the value of your money decreases with time. What is the assumption you would make? Is it going to drop by 2%, 3%, and so on? So the benefits can only be assessed as discounted present value of your investment for the future. It could be 10 years into the future, 25 years, 100 years, whatever. Okay, so as a result, discounting has obviously a big impact and can be a big knob to change the values. Okay, so here is a typical integrated assessment model, which considers GDP, population, policies, various other assumptions, looks at economy, energy systems, land and climate, and looks at economic outcomes, emissions that would result from these choices, energy pathways to meet certain targets, and land use that is involved. For example, afforestation, more sustainable land use, agriculture, etc., etc. Okay, so here is an example from the book, The Social Cost of Carbon. What is needed to produce a number in one model? This is from this particular paper. Looks at socioeconomics we talked about, population, income, converts it into the energy use and the resulting emissions into the future. So there is the CO2 pulse and what it means in terms of the social cost. Here is the chopper again. I can pause it and restart it. Maybe that's a better way of... Okay, recording again. What is involved? So we have population, income, emissions, how it affects temperatures after the CO2 pulse. You can see the change here. Regional temperature change, regional sea level rise. So you need the numbers as specific, as region specific as possible, and estimated climate damages. So you have to go from here to there. Okay, so obviously not as an easy task, but that's what these integrated assessment models are built for. So I mentioned discounting. What is discounting? Discounting basically translates the value of, maybe I should do this in the next module. Yeah, let me come back to discounting in the next podcast. But I hope you got the idea of the social cost of carbon. It's how an additional ton of CO2 emission cascades through the socioeconomic system and ends up in causing a certain amount of climate impact and damage to the systems we mentioned before: food, health, productivity, etc. But it also tells you how much an investment in reducing 1 ton of CO2 emission would result in the benefits in the future. Anytime you say in the future, economists want to use this discounting rate because the value of $1 today is going to be less tomorrow and day after and so on. It's like borrowing money and delaying the repayment because you want to exploit that loan to your benefit and pay a certain cost for the loan. Okay, so I'll explain it with the in the next podcast.